All right, I should be recording now. So I wanted to talk to you guys a little bit about integrals and the math behind them to make sure that you can do basic integration. You don't get too far into integration in this class, just a little bit. So we're going to talk about the things that you will run across. Um, so what is an integral? An integral, or in any derivative, it's pretty much the same word. It does the opposite of derivative, or it undoes the derivative. Okay. So it's the opposite, like if I square a number and take the square root, they're inverse functions of each other, and that's true of integrals and derivatives mostly. So for example, we know the derivative of x cubed is 3x squared. So we can say the integral then of 3x squared is x cubed. So it undoes the derivative with one little exception. So they denote an integral with this funky little sign here. This says the integral of 3x squared. Dx is just telling me I'm doing the integration with respect to x. It's the variable. So I said that's x cubed, but plus c, all right? So why the plus c? C is what they call an arbitrary constant. This type of integral is called an indefinite integral. Later on, you'll be doing things that, definite integrals, they have numbers here, and we'll talk about those probably next week. But so an indefinite integral, all the indefinite integrals like this need the plus c. And the only ones that the indefinite integrals with the numbers don't require a plus c. All right, so let's see why. So let's take the derivatives of each of these three functions. So x cubed plus 3, the derivative is 3x squared, right? And the next one, the derivative is also 3x squared because the derivative of negative 6 is 0. And the derivative of x cubed is still 3x squared. So all three of these functions have the same derivative with the exception of a constant. Because we take the derivative of the constant, it goes to 0. And so when I do the opposite, I have no way of getting that constant back without some more information. So that's the reason for the plus c at the end, the arbitrary constant. Okay. All right, so basic integration, just integrating powers of x. So when you differentiate, this should be the word differentiate. When you differentiate powers of x, take the derivatives. Normally, I multiply the exponent out front by the number, and then I lower the exponent by degree by 1, right? So if I have 3x squared, I multiply 3 times 2 is 6, and I lower it by 1. All right, so to do an integral, we do the exact opposite thing in the opposite order. So what we're going to do is we're going to raise the exponent by a degree of 1. So for x squared, we get x cubed. So I raise the exponent first, and then I divide by the new exponent. So it's x cubed over 3, right? So plus this little c thing. All right, they could also write this as 1/3 x cubed plus c. It's the same thing. Okay. All right, so basically the basic formula for integration of x to the n then is x to the n plus 1 divided by n plus 1. So we just raise it and divide by what we raised it to, plus a constant. Okay, so we'll do some practice. When you have a number multiplying an integral, the number can come out. So it's 4 times the integral of x to the 5th. The number doesn't do anything when it's multiplying. So for integration, I'm going to raise the exponent by 1, so it's x to the 6th, and divide by 6. So I can make that 2/3 x to the 6th, again, plus this arbitrary constant. Don't forget the constant. All right. So this guy here, we're going to do the same thing. Okay, you have 3 and the integral of x squared. You're going to raise it by 1, x cubed, and divide by 3. Let's cancel. Minus 6, raise the degree by 1, so this becomes x squared over 2. And the integral of 1, so remember the derivative of x is 1, so the integral of 1 is x, so we're going to put plus x, right? And so you can simplify it, make it look pretty, minus 3x squared plus x, and again, plus an arbitrary constant. Okay. So this next one, same thing, the integral of t to the 5th is t to the 6th over 6. The integral of t cubed is t to the 4th over 4. The integral of t is t squared over 2. And the integral of 2 is 2t. Right, now I just simplify the numbers. So let's see, it goes in 10. This would be 10 over 3 t to the 6 minus 3 over 2 t to the 4th plus 1/2 t squared plus 2t plus c. Okay, so that's integrating, how to integrate a polynomial, just one term at a time. All right, so there are some fractions that are going to have x's in the denominator and only x's. So what we're going to do is, but when you have x's in the denominator, if you only have one x term, you're going to rewrite it. You're going to rewrite it with a negative power. So remember, if it's on the bottom, first you have to rewrite it. So I'm going to rewrite this as the integral of 2 times x to the negative 2. All right, so that's how I rewrite it. Now I can use that power rule. So I'm going to raise the power by 1. So be careful with this. You're not going to negative 3 because negative 2 plus 1 is negative 1. So it's 2x to the negative 1 divided by negative 1. And I can rewrite that as negative 2 over x plus c. Okay, so remember the negative exponent means it's downstairs. All right, so this next integral, kind of the same thing. I'm going to rewrite the negative powers. So it's the integral of 3x to the negative 6 plus 2x to the negative 2. And the rest is good. All right, now we just integrate it. So you raise it 1, it becomes 3x to the negative 5 divided by negative 5 plus 2, I'm going to raise that, it becomes x to the negative 1 over negative 1 minus 3x to the 5th over 5 plus 5x. All right, and just rewrite the negative exponents. We'll make it look pretty. So this would be negative 3/5 over 3 over 5x to the 5th. Just put that on the bottom. Minus 2 over x minus 3x to the 5th over 5 plus 5x plus c. All right, and there's my integral. So if you have a simple negative exponent on the bottom and a negative power, or negative x on the bottom, or x power of x on the bottom, go ahead and rewrite it as a negative. And this is true of radicals too. You really can't integrate a square root, but you can always write radicals as powers of x. So let's review these real quick. The square root of x, we could rewrite as x to the 1/2. Remember, you divide by the index. The index here is 3, so this would be x to the 1/3. If x is on the bottom, well, it's going to be a negative power, so x to the negative 1/2 for 1 over the square root of x. And this guy would be written as 3/5. X, it's going to be negative, it's on the bottom. Keep the power and divide by the exponent. Excuse me, I'm going to pause this right now. Hello? Hey, what's up? Sure, where are you going to get it from? Okay. I have not had lunch yet. Sure. 10-piece chicken nugget. Yeah, you know what I want. Okay. I'll see you in a bit. Okay. All right. Bye. Okay. Let's make sure I'm still recording. I am. All right. So now that I've rewritten them, it's a simple matter of integrating them. So the integral of x to the 1/2. Now, with fractions, you're going to have to raise it by 1. So 1/2 plus 1, you can type it in a calculator, but it's 1/2 plus 2/2. So it's x to the 3/2. So to divide by 3/2, just flip the fraction. So it's times 2/3. Just go ahead and flip the fraction, plus c. Okay? And you can leave it like that. All right, the integral of x to the 1/3. So if you're going to add 1 to it, 1/3 plus 3/3 is 4/3. And again, you can type it in a calculator if you need to. Divide by 4/3 is the same as multiplying by 3/4. So just go ahead and take the reciprocal and multiply. All right, to integrate x to the negative 1/2, raise it by 1. So negative 1/2 plus 1 is 1/2. Dividing by 1/2 is the same as multiplying by 2 over 1. So that's multiplying by 2. All right, let's do the last one. So 3/5, I'll just put that out here. So negative 2/3 plus 1. So negative 2/3 plus, oops, do I write it that way? Negative 2/3 plus 3/3 is 1/3. So it's going to be x to the 1/3. Divide by 1/3 is the same as multiplying by 3. So I end up with 9/5 x to the 1/3 plus c. Okay, so any radical you have, you're going to want to rewrite as a power, always. Okay, so there's one exception to the power rule. The integral of 1 over x. So if I rewrite this as x to the negative 1, if I try to use the power rule, I raise it by 1, I get x to the 0 over 0. And you know that's a problem because you can't divide by 0. So what you have to keep in mind is this is the exception, because we knew, or we learned, the derivative of the ln is 1 over x. So really when you integrate 1 over x, guess what? Its function is ln x, all right, plus a constant, okay? All right, so that's the one thing. So if I want to integrate 3 over x, you can pull any constants can be pulled out of the integral. So I'm going to pull the 3 out. It's 3 times the integral of 1 over x. And of course, I know the integral of 1 over x, it's a formula, it's ln x, because the derivative of ln x is 1 over x. So it's 3 ln x plus c. Okay. One last integration formula that you probably need. Remember the derivative of e to the ax, like e to the 2x or something like that, right? Was a e to the ax, so it's 2 e to the 2x. So you multiply by the number, and so guess what? With integration, you do the opposite. So rather than multiplying by the number in the exponent, you divide by it. So there's your formula. So the integral of e to the 3x would be 1 over the number inside, which is 3, e to the 3x plus c. So just divide by the number rather than multiply, okay? So e to the negative 1/2 x, you still just divide by negative 1/2, so it's e to the negative 1/2 x. So dividing means multiply by the reciprocal, so you're going to get negative 2, e to the negative 1/2 x, again, plus c. So with e's, it's real easy, you just divide by the constant. Okay, so here's a summary of all 3 integration formulas. Okay, and keep in mind here with the power function, the power of x, no, that's n. N cannot be negative 1. All right, if n is negative 1, we're going right here. All right, 2 properties of integrals that we've been using or will use is that you can always pull a constant, a number, out of an integral if it's multiplying a function. So if there's a 2 next to f of x, you can pull the 2 out of the integral. You can never pull an x out of an integral, only numbers. And the integral of a sum or the integral of a difference is the integral of the sums of the differences. So you can always split a sum apart and a difference apart. But you'll notice that this says nothing about products or quotients of functions. You do not have the ability to work with that. There's no product rule or quotient rule for integrals. There are techniques that you can use, but again, most of them are beyond the scope of the course, so you don't have to worry about it. All right, so not everything is integrable, I should mention. So like, you know, if I have a function rather than a number here, like e to the x squared plus 2, you know, something like that, maybe plus 2x or something, I can't integrate that, so that's okay. I mean, there's going to be things that you cannot integrate. All right, so like, what else could we do? We could do a quotient with, you know, maybe later on you could integrate this, but this is not going to be something you can integrate with quotients. There has to be one term in the denominator. So things like this, they may not be integrable. In fact, this first one is not integrable ever. So there are some integrals just can't be done, but there's no product rule, there's no quotient rule. So we're kind of stuck there, but our limitations, we're going to be pretty limited, all right, in this. All right, so if something looks like a product or quotient, then you're going to have to fix it algebraically by multiplying things out or dividing. There's another technique covered called substitution, which I'll cover in my next video. So let's talk about some of the cases where you have to simplify algebraically. So if you have one term in a denominator, like a monomial, that's the one term, you can divide it out and then you'll be able to integrate it. So like this first integral, I could rewrite this algebraically as x to the 2/3 over x. So remember, both of these are dividing x plus 2 over x. And I can simplify this by subtracting the exponents. So this is 3/3. So 2/3 minus 3/3. This is really x to the negative 1/3 plus 2 over x. And this is something I can integrate now, term by term. So this one I use the power on. So it's x. If I add 1 to it, you're going to get 2/3. So I'm going to multiply by 3/2. The 2 I'm going to pull out. And remember, the integral of 1 over x is ln x plus a constant. Okay, so if you have a monomial, one term in the bottom, go ahead and divide it out. Like this looks really scary, but you can't deal with it. So we're going to break it down and we're going to just divide everything by x cubed. I'm going to write the square root as x to the 1/2. So every term is going to get divided by x cubed. So those cancel. So I have the integral of e to the 2x plus, subtract the exponents, 3x squared. Okay, 1/2 minus 3 is going to be negative 2.5, right, or negative 5/2. I'm going to write it that way. But now I have something that I can integrate once I simplify it. So the integral of e to the 2x, remember you divide by the 2, so it's 1/2 e to the 2x. The integral of this guy would be x cubed, and the 3 on the bottom is going to cancel with the 3. Minus 2, okay, raise the power. So negative 5/2 plus 2/2 is negative 3/2. And again, then multiply by the reciprocal of the exponent. So that's times negative 2/3. So I end up with 1/2 e to the 2x plus x cubed plus 4/3. I'm just going to leave the negative exponent. Most of the time they're not going to care. Plus c. Okay. All right, so sometimes you'll have an e to the x in the denominator. Don't let that throw you off. That can also be rewritten. It's the integral of 5 times e to the negative 4x. So remember, that's just a negative exponent. And I just follow my integration rule. So I'm going to divide by negative 4. So it's negative 5 over 4 for e to the negative 4x plus c. So that's an easy one to integrate. All right, at this point in time, if you have a product, you don't have a product rule, you can't integrate them separately, so you just have to multiply them out, all right? So if I had something like this, I'd multiply it out, I get 9x squared plus 9x, I just distributed the 9x, and then I can integrate each term, so it's 9x cubed over 3 plus 9x squared over 2. All right, and you can simplify that. All right, be watchful of something like this. 2x plus 3 squared. Remember that you cannot just distribute the square through. You're going to have to FOIL that out, so you're going to have to multiply it out. 2x plus 3 times 2x plus 3. You're going to integrate, let's see, so if I do the first, it would be 4x squared. The outsides would be 6x, and the insides are 6x. So altogether, it's 12x. And the last would be 9. And once I multiply it out, I have something I can integrate. So it's 4/3 x cubed. I'm going to raise it, divide by 2, so I get 6x squared. Integral of 9 is 9x plus a constant. Okay. All right, so this is pretty much your basic integration. It's what I can see running across. Hopefully this is helpful. This should give you enough to do the Pearson homework. All right, and I'm going to stop that.